Okay, so now we are going to start back differentiation chapter. Okay. Last week were you here? I don't think so, right? Last week. I think last week you didn't come yet. So okay, never mind. We will continue with differentiation. I did the first half already. I think last week no class. So last week. So then last week I think you were here. So that was the first half, and then now we will continue with the second half of differentiation. So before differentiation, I actually want to show something about the SPM actually. So you can see it from here. I actually shared it in the group as well. So it's like basically the info on your SPM paper, like last year's one. So you can see it from here. Can you see this one? This one I'm showing here. Did I share it? Okay. So, okay, this one, right? So this was actually the paper last year. Okay, yeah. So this one is from a Taklimat lah, something like that. So this was from last year actually. I get a pen. Okay, so it's teknik menjawab dan menguasai. So I see tough topics, tough topics. So this was actually the first format, first year of KSSM last year lah. So what is given continuously from here is all up to date. Like you cannot take the 2020 info because it's a different batch altogether. So you have to base on 2021. Now our year is 2022 lah, the one we are going to see it for. Okay. So the topics that actually came out in paper 1, okay, we're talking paper 1 now. Paper 1 of SPM 2021. So first question was actually circular measures. So just to inform you lah, to be aware of these topics in maths. And then another one is linear law, 4 marks. Paper 1, usually the marks will be lower because total is 80 marks. You must remember that. 80 marks only. Paper 2 is 100. Okay. So far, how are you with these two chapters? Honestly, first look. I mean, circular measures and linear law. Paper 200. So basically, these two topics, the first and the second one. Circular measure, no problem. I think, okay, good. So how about linear law? So I can put a tick already. So maybe after you tell me all this, then I know which topics to like focus on. A bit non-understanding. Okay, linear law, we put a star here. And then how about progressions from 4? This was the third question, okay? Third question that carried 5 marks in paper 1. What is okay? So now I know it's in your form 4, chapter 5. So I think that one also I will go to a bit. Actually, we have questions on it, so we will finally reach it also in the end. And today's one, we are doing this one, differentiation. This is what we are doing today, pembezaan. Okay, this one. So after this, you'll be clear lah. So this one, nothing. And then the another one is quadratic function. I think I did with you. How is your quadratic function? Quadratic function is form 4, chapter 2. It carried 7 marks. I think okay also. Okay, so it's not quadratic. Circular measure. See, again, it came out. You see, within the same paper, right? Same section, they came out 2 questions, 2 separate questions on circular measure. You see here? 6 marks here and 2 marks here. So total, you already get 8 marks out of 80 lah, if you just answer that 2. So the 7th one is actually vectors. Vectors, are you okay? This was section A lah. Section A is from number 1 to 12, I think. Yeah, number 1 to 12. So still in section A. Nope. Okay, so this one I'll put a star. So, and then coordinate geometry. After differentiation question, actually going to this. So this one I don't think you no need to reply to this one. This one we will go to anyway, the whole chapter. So integration, I think I taught you. I think we did that question, remember, in section A. I showed you the thing. I think integration should be all right already. Integration and differentiation are basically interrelated. So if you know one, you know the other already. So that's why I'm doing differentiation today. So it's just the opposite of each other. Progression, another star. That one I have to explain a bit. Permutation and combination. You learn this chapter? Chapter 5, Form 5, Chapter 4, number 11. This one is also actually quite a tough chapter even for me. Let me see, okay. If you want, I can also put a star lah, just in case I can explain further in depth also for number 11. So that one actually carried 7 marks in number 11 of section A in the SPM. Usually permutation, I didn't learn it. Okay, we'll put a star there. And then probability distribution, did you learn? Form 5, chapter 5, number 12. One carried 4 marks. Usually it's binomial distribution and normal distribution also. Okay, I know it. I think you stopped at chapter 3, right? In school. Chapter 1, 2, 3. Then 4 onwards you didn't touch. So okay, now I know. How about functions? I think this one you did I go to the I think I went to this. Functions chapter 1 of form 4. Carried 8 marks. This is section B onwards. Section B, you choose 2 out of these 3. It's a dividing segment here. No longer I chose a different color, so highlighter better. Yes, okay, so you're good at it. So this one is cleared. And then another one, index search and logarithms. Form 4, chapter 4. Among the choices of questions in this section. Index, no, that's a chapter 10, form 4. This one is chapter 4, form 4. Indices, search, and logarithms. No, block is confusing still. Okay, so this one I'll put a star still for the whole chapter, even though it's just the log part. Okay, so I will circle up the log. Okay, then this is a tough chapter. Trigonometric functions. This one you didn't learn, so I better put a star here also as well. This one is chapter 6 of form 5. So, like I will consider this as the hardest in the whole ADD MATHS syllabus because this is actually one of the higher level stuff It's not like the one you learn in lower form maths. Is like up one level from your not basic trigo that you saw in your maths, like sine, cosine, tangent, right? We add 3 more trigonometric functions to this basic 3 here. So you will discover that in that chapter. So you have total 6 trigo functions. You must remember that. Don't only think that there's only 3 functions of trigonometry. There are actually 6. That's what ADD MATHS told in this chapter. Okay. So now as a conclusion, right, from paper 1, you see, right, what is the thing you can notice here from all this? Can you tell a conclusion for me? This part. Based on the questions and marks, how are you going to divide your attention, your priorities to all the topics? This is based on the analysis, this is the actual data actually. This one actually, usually paper 1 is 80, not 88, because 44 plus 44, you get 88, 88 marks. But that is because of the third question, you choose 2 out of 3, right? So another question is plus 8, that's why you get 88. The total you get is 80 only. So what do you think? You see here, right? The amount of marks over here. I explain. You see the total marks here for Form 4 topics and Form 5 topics, right? Can you see that they are equal? Although the number of questions are different. Form 5 actually came out more topics than Form 4. But I can say almost equal. So because 7 and 8 is not a big difference anyway. Because you see, this part, you can actually cancel off this Form 5 chapter. Because this is what? Choice, multiple choice question. So if I take off 15, this Form 5, right? So it's actually equal in the end. 7 questions from both forms. So paper 1, right, you can notice the trend that both forms are equally important. You see here? And the marks are the same also. So you cannot only focus on Form 4. Because you only focus on Form 4, let's say, this is also if you get full marks, 44. All of it you cover. Or let's say you cover only Form 5, you still get 44 also. But if you minus the 3 go, you only get 36. 44 minus 8. So you see here, is either you want this or this. Or maybe it'll be around there. Let's say you just focus on Form 4, maybe let's say I minus, how many on the minus 8 marks? Maybe you get 36. If you focus a lot on the Form 4 topics from now. So let's say I give you 36. Okay. So now we see paper 2. Paper 2 is more marks. So definitely more marks for each question. Okay. So first topic is system of equations. Let me see on top. System of equations, nothing. So how's your system of equation? I think I taught this also. Chapter 3, Form 4. No. Paper 1 is also like something I would say like structure. It's like there's no objective in ADD MATS. Remember that, no? It's not like maths. Maths paper 1 is objective. That one you're right. But in ADD MATS, there's no objective. It's all subjective. This one is the more subjective paper, I will say. Paper 1 is like short answers like that. But it also requires working. Got working doesn't mean paper 1 no working. Only the working is shorter. It's like more direct. The questions is facts. But paper 2 is you must apply your knowledge to an application question, let's say from any topic. That's why the working comes long. You need to combine knowledge from various topics and all that. Okay. So system of equation, you see, right? Are you okay with it? This number 1. Then it's chapter 3, Form 4. It carried 5 marks. Equation, yeah. This one is actually quite one of the basic chapters that you also find in your maths, actually. Linear equation, something like that. Simultaneous linear equation. I think you should be okay with it. Yeah, okay. So this one I'll put a tick. Index search and logarithms, just now you said not so good logarithms, so I put a sign here. So for logarithms, function, you're okay. And then function quadratic, did I put anything? Yeah, I put tick also. Trigo I have to teach. This one is must because it's a new thing. Vector, what do you say? Vector also must. And then differentiation, this one I'm doing today. These 2 is okay already. This one I will do after. So hukum linear, this one you need also. And then these 2 as well. This one's a new one. Kinematics of linear motion. This one is actually in section C, paper 2. You choose 2 out of 4 questions. So this one you can omit if you want. But this one will definitely is confirmed to come in section C. I divide here. Until number 7 is section A of paper 2. Number 8 to 11 is, let me think, section B, I think, yeah. 8 to 11. 12 to 15 is section C. So you see, always this one will appear in section C. It won't change. These 4 topics, right, is fixed already, section C forever. So among these, you are going to choose what's going to happen in the exam. So this one I can omit because I don't think it's like quite complicated also. Index number, I think you're okay. That one I taught you at the very beginning, I think. I did the whole chapter, this one. Index number, that's what you were talking. So I think it's one okay. All these are 10 marks. From section B onwards, all 10, 10, 10, all the marks like that. So you'll add up. You see the marks here are more for each question compared to the top. See here? The marks are like distributed around 4, 5, 6, 7. But here you see, it comes to 10. So you know the importance of this paper. So next is solution of triangles. Are you okay? Number 14. Yeah, good. Okay. So this one I can omit if you want. Linear programming is something like your linear inequalities you did in your maths actually. You will find the linear inequality, then you'll shade the region. Remember that satisfy all the inequality. That is linear programming basically. It's same like maths only, but I can omit it also. I just put a star just in case maybe we can come to it also. So now you see, right? You notice here, Form 4, right? In the actual SPM last year, came out 9 questions, whereas Form 5 came out 6 questions. So you see the difference here, right? Just now it was equal. You see here, paper 1, right? Equal 7 to 8 is about there. But you see the difference here, 9 to 6. So you know where is the more important topics coming from. See, which form you have to focus. You see, Form 4, your basics. Form 5, you see, only came out 6. And 6 also is also because of these topics like linear programming and kinematics. So if I minus that, right, it'll only come 4 questions that you will actually do in the exam. So 9 versus 4, you already know which one is more important. I make it more apparent to you. So this one you have to choose. So you have to focus this to get 74 marks. Okay? So do more revision on Form 4 for your paper 2. So let's say I give you 74 and then I minus off Form 5 also. Let me see. I minus 20, let's say. Okay? You get 54 here. Let's say so here I put was, let me see where is it. Here I put was 36. So basically for ADD MATHS, right, you know how they count is how much you get over 180 times 100. This one you need to know so that you know where to target your marks at. So pass is 40, right? So if I count, right, let me count now. 40 over 100. 180, let me count now for a while. For X, okay, 40 over 100. 40 times 180 over 100. Okay. So passing mark is here, I write here 72. Out of 180, right? You must get 72 marks out of 180 to get 40% for ADD MATHS. Okay. So these 72 marks are going to come from your paper 1 plus paper 2. So you can see here now. Where are you going to get the 72 marks? You have to find where's your strength. So here, right, you see I already put 54. Here is 74. Remember that if you score full, but that one is quite hard. So you need to target to the highest ability you can. So let's say 54 I put. And then here I put was 36. Safe already. Let's say I can even minus more. Here 54 plus 36 is 90. 90 minus 72, you can still lose 18 more marks from the ones I gave you. Then you get 72. So you got some leeway there also. So you can focus on a few topics that will give you the marks. Let's say the topics you said you were good at, right? Circular measure, 2 marks. Let's say I give you here. This one, once I tick, I'll give you full marks. 9, 15, 20, 28, 28, And then, of course, you have to study for the rest lah. 33, 40, 47, 57, 67. You see? 67 total you must get is 72. So you only need 5 more marks. From the other topics you told me you were not good. You already got 67. If you do perfectly all the ones you were good at. You see here? You just need to put effort for these 5 more marks. So this is where you have to focus lah. Yeah, maths. Okay? Clear how I count everything. Okay, so good. So one more thing I want to inform you. Now I'll start the day after this. So one more thing I want to inform you is about this formula list. You'll have it in your front page, right, in your paper. So this one, right? Usually the standard one is, wait, let me see. Standard one is 24, I think, if I'm not wrong, lah. Amount of formulas given. But what happened is, right, you see here, can you notice the amount of formulas they gave? Up till number 44, minus 24, right? There's an additional 20 formulas that they actually gave you. Not gave you, like I saw it in some trial questions. So you can see here from other states lah. So don't expect, right? This SPM, they're only going to give you 24. So if you're lucky, right, they can actually give you up till 44 also. So this is one more good news lah. I found from other states. So you can see here, they can give up till 44 formulas. And it covers all the topics. You can, I send this in the group already so you can see. So yeah, but just in case, try to memorize formulas. So don't depend on this that they'll give you 44 formulas. It might be 24 so for your SPM, okay? So you need to memorize formulas. Okay. So yeah, that's about it. And now we will go on to the lesson. So I just brief you on this lah. So far, okay. Things should be okay. Yeah. Right. This one cancel. Okay, so now we go back here. So now we will go on to the real one about differentiation. Okay. So what we are going to start with differentiation now is actually rate of change of related quantities. Okay, so make sure you have your notebook beside you so that you can jot down the notes I tell, like how I bring out the whole thing. Okay, so first of all, can you see the board clearly or not? Like from here, I'm not so sure. Based on what I wrote there, can you see anything? I think you can see, right? Slightly blurred, huh? Is it better now? I increase the brightness slightly. Tell me whether it improves or not. Okay. So now it's brighter. Yeah, I feel it's better. So, okay, so now we'll start with differentiation. Okay. For differentiation, you're going to do rate of change first. So this part is slightly, you have to know a lot of formulas lah. Differentiation chapter is mainly all about formulas. So you need to practice questions to make sure the formulas go into your head lah. So yeah. So only 2 questions you can learn, but I explain the theory part lah behind it. So rate of change of related quantities, right? Okay, so let's say we try to, this is a subtopic line in the textbook, that's why I tell it here. Okay, so first of all, you need to know what is rate of change. What do they mean by rate of change? Do you know what does rate mean? In maths, of course. when you see the word weight, what is the physical quantity that comes to your mind? Constant, not constant. That one is it can be constant weight. Yeah, you're right also. But what does weight mean by itself? The meaning of the word weight. Increase or decrease? Yeah, correct. So what is increasing or decreasing actually? What is the quantity that increases or decreases? What is what increase or decrease? Something very important. Yes, correct. Time. Very good. So you see, rate of change means you're talking about the time because it's rate. So the unit we give is actually per second. So second negative 1. Per second you will see as 1 over s. This is what we call as per second. Okay. Means you want to find what they're actually trying to tell you here is the rate of a quantity changing in 1 second. So this is what they want to tell you. Any quantity like can be based on the question. So now we see the next part, related quantities. So what are examples of related quantities that you know? Related quantities usually will come from a formula. Any formula that you know. You study in your lower form maths also, we have seen some formulas. It can be also from your this thing, what surface area and volume of shapes. You can also tell quantities like that. So what kind of things you know? I don't know. Okay, wait, I give an example. Let's say speed. Do you know this formula? Speed is distance over time. Yes, okay, good. So these are actually related quantities. You see the time here, right? This is what I meant by weight actually. Per second means your quantity distance, right? You per the second. See here? This is how you got the rate of change because rate means time. So you see here, speed and distance are the related quantities. Time is not related quantities. Time is this part, the rate of change. Related quantities is this one over here. Speed and time. Speed and distance. Related quantities. So how do you think they're actually related? You have to see based on their unit. So if I say they are related quantities, speed as a unit of meter per second, I think this one you should know, right? I think usually we will use this in when you calculate a lot of things in maths also, like graphs of motion, all that. The unit for speed is meter per second, and the unit for distance is meter. So you see they are related. You see they share a common unit, which is meter. Meter per second and meter. See the similarities there? So that's why they are related quantities also. Because of the distance involved. Okay. So yeah, this is one of it. So far, okay. I analyzed the word already. Okay, good. Now we will go on to the formula. I'll try to introduce the formula to you. Okay, so formula of related quantities, it goes like this. After we discuss about the topic, we will go straight to apply on a question so that easier to understand how it comes out the question. So the formula of rate of change of related quantities, you see, they will always give you two variables. This is a condition. So that's why just now I showed you speed and distance. They are also variables, because they are changing. What? However, speed and distance will change in a motion when you move. You travel further distance, you might increase your speed. So that's why they are changing always. So two variables, x and y. Let's say I give a variable. Let's say speed is x, distance is y. Common, right? You see like this. They'll ask you to assume x and y. So they say change with time. Sometimes you don't need to put variables like this, so x and y. You can straight away use the front letter of these things. Speed usually we represent with v. Distance we represent with d. Okay, so you don't need to actually put x and y also. I'm just telling. So you see these two. These are what variables. So whenever you have alphabets, means it's variables. So change with time. So then the formula is like this. So it is dy over dt is dy over dx times dx over dt. This is one type of formula that they can come out with. Okay, so this is a formula that we use. You know why they actually say this one is equals to this, isn't it? Can you see why this can equal to this? Do you see a relationship there? Times, yeah, correct. That's a relationship, time. So when times, right, can you see the denominator is dx and the numerator here is dx? Can you see this? Up and down. When they are up and down, what we usually do in maths? What can we do to simplify this expression on the right here after the equal sign? Cut, yeah, correct. If I cut this, do I get this one? If I cut these two, you see what you will get from here. So you see, that's how you relate rate of change of related quantities. Means you will put like two formulas here and make it equal to this one when you times it. That's why they say this one is equal to this times this. Okay, so that's how it is done. So let's say we apply to a application question this thing. Let's say I give you a cylinder or something like that. Or we go directly to the question I sent the group also better. Check your WhatsApp group. I think I sent the question on this thing. Wait, the latest message I sent. I sent a PDF with 3 pages on differentiation. See number, let me think. Number 12A. 12A, they ask rate of change of F, right? That question. Can see, right? Okay, good. So we are going to do this one. So I'll show how we actually do it. So I write down here just in case. Variable f and g are related by the equation 1 over f. So it's a bit complicated, right? When you see this equation directly like this, usually the question will give you in this form. From here, right, you need to modify the equation to a form that can help you modify to a form that can make you apply differentiation. Because from here, right, you cannot directly differentiate this equation because it's like a fraction plus a fraction equals to a number. You cannot differentiate this. With differentiate, you can only apply, let's say, y equals blah, 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 x. Then we can do dy over dx, right? That's the basic of differentiation. You must express this equation in another term. So there's two possibilities here. Either you want to express f in terms of g, or you express g in terms of f. Means either way, they're opposite to each other. So now we have to depend on the question. Because I don't think the question will give you choice to do either method you want. So let's see. So they gave an info here. Must always see the info. G increases at a rate of 1.2 cm per second. Okay, so this is the unit. Means it's something like the length. Cm is length, right? So they're actually trying to tell you that the length increases by 1.2 cm in 1 second. So let's say I ask you from here, if after 3 seconds, let's say I assume the rate of increase is constant. Rate of increase. You have to make this kind of assumptions, else you can't calculate anything in maths. So what will be the length after 3 seconds based on the value they gave here? 1.2 cm in 1 second. So 3 seconds will be what? What's the length? Ratios and proportions, this one. Based on this one here, 1.2 cm as -1. So what will be the value of the length? Actually, this one's basic times only. Just times one thing with another thing, you can find out what will be the value. 1.2 times 3, yeah, correct. So you get 3.6 cm only, means length is cm, right? So you see here, after 3 seconds, the length will change constantly. So this is what they're telling you here by g increases at the rate of 1.2 cm per second. Means in 1 second, it increased 1.2, then 2 seconds, 2.4, and it continues until the end of the question. Okay, so now the question comes. Find the rate of change of f. Okay, so now basically they are trying to ask you to find what is the f value in maybe cms per second also. I don't know, I'm not sure yet. So rate of change means definitely going to involve time. That's one thing you're sure. And they are telling about this quantity f here based on this equation. So this is how we're going to think how you want to solve this question. Okay, so yeah. So rate of change of f. This is the question, right? In CMS -1. So the quantity is the same here. I mean the unit. So when G is 20 cm, you will need to use this later. You will know why. Whenever they give info like this in the question, you must utilize anywhere you're working when you're solving. Usually they'll give like this in the exam. So you can sub inside the G variable. Okay. So yeah, it's like this. Anything else? Don't think so. Yeah, can go direct to the solving already. This one is 4 marks. So it's not that long. This should be a paper 1 question, I think. And this came out in one of the trial questions. Latest one, no? You know this one, right? A famous school, MRSM. It came out in their trial in this year, just so this was the question actually. So I'll share like up-to-date questions. So we'll try to solve this. So first you need to know how to modify the equation. Okay, we'll go to the solving part now. I'll keep the question here. Let's stop here. Actually, in the answer scheme, they also gave two possibilities. Either you want to express G in terms of F or F in terms of G. So it's open. You can do it any way you like, actually, based on it here. Means you can either one from this equation, right? You can do these two steps. Either you make G on the left hand side, then everything on the right hand side is F, or everything on left hand side is F only equals to everything is G on the right hand side. So if I ask you to modify this equation, can you tell me what is F in terms of G? Can you simplify this? Like F equals something, something, something G. That's your end result you should expect. So you need to know how to modify fractions into an equation. So try doing that first. You tell me the final answer what you get. Or if you start, you can like tell any questions you have. Make sure you know your steps, how you're going about it. If you have like the thought process also, you can share like that, like how you want to start off your working, like what step will you take. You can also share the one, then we can go from there step by step. Or if you're confident, you can directly share your answer. This one is my first thing. Let's see whether I can identify whether you can do this first step or not. If you do this first step, let me check. If you already do this first step correctly, right, you already get 1 mark for this question based on it, based on the marking scheme. Wait, this one got one mistake here. You might get the wrong answer. Don't start it. Stop first for a while. This one is 1/15, not 15. Modification here. 1/f plus 1/g is 1/15. Okay. That's why sometimes it's also very important, like for all of us, sometimes you must copy the equation correctly in the first place. If you copy the wrong one, even if you know how to do, the whole thing will go wrong anyway. So yeah, when you transfer the equation to your working, you must be careful also. Remember f in terms of g, yeah? F equals 15 times, is that x or times? Times, wait, no, let me check. Can show your working. You got the first part correct, but there's a fraction. Do you get any fraction after you shifted everything? Just got f is 15g. Should be over something. F equals 15 times 1 over g. 1 over g means you get 50, means you'll get 15 over g lah. Is that how you wrote down? Wait. Do you use 15 or 1 or 15? Did you change already to 1 or 15? When you start copying the equation, the first step. Yeah, I change it. Wait, can show where's how you wrote it. I can see where's the part you mistake. I did in my mind, then wrote it. Oh, you must do on the paper, not your mind. Then you'll get it right, right? Means you solve directly from what I wrote, is it? From 1 over f plus 1 over g is 1 over 15, you straight away gave that answer. Did you do like that? If you do like that, means cannot. Because in advanced, you need working also. You cannot just like directly from that, right? You straight away write that answer that you gave, that f is 15 over g. You might not get the mark because you must show all the necessary workings. They'll tell you that in the paper. Like every step you must show, means you must do it manually in other ways. You cannot use like calculator or any stuff. You must show it manually. Oh, wait, must be. Yeah, unpin. Okay, let me see. 1 OF, wait, this thing popped out. 1 over f plus 1 over g is 1 over 15. Oh, you times like that. Cannot. You must make, I'll show you how to do it. You can stop share first. I'll show you here. Wait, it's here. See here. From this side, you need to make the denominator same. What you did is you times 1 over 15 with g, right? That one cannot, because here's 1 over g. If you want to times, so you times 1 over g, not g. But even that is wrong lah. So you need to see here, when you have 1 over f plus 1 over g, right? You must make the denominator same. So what I do here is I take fg as the denominator. Can you see that? Means I like equalize these two. Can understand this step? Okay. Okay. So after this, right? you need to take off the f, means you put the g here, plus the f, you get 1 over 15. Okay, understand this step? When you have f and g, right? When f times f, you must cancel it off, then you get g. Okay, yes, understand? And then next one, I ask you to express f in terms of g, right? So you see here, let's say I get 15g plus 15f is fg. So f in terms of g, right? So how you do it is 15f minus fg is negative 15g. You understand up till here, right? Yes, huh? Okay. I went this side, make sure you know. So when you shift this 15g this side, be careful, must put negative, huh? Because from left hand side, you shift to right hand side, you must add negative here. And then this one I shift here, so I minus. Okay. So after this, I say f in terms of g, right? So how you want to convert this one so that it's just f on the left hand side, because it's 15f minus fg, right? So what I do is I take out the f. So you get f bracket 15 minus g. This is what you call as factorization method. You understand this one, how I factorize from here to here. Right. Okay, good. So from here, right, I just copy back this side, lah, negative 15g. So from here, you will get f equals negative 15g over 15 minus g. This is your f in terms of g. Means I shift this one over here. When it's times in between here, you must divide. You understand? Things should be okay, right? So this is your f in terms of g actually. The down one here. Yes, okay, good. So this one is here. So after you got this is where you show off your differentiation skill. Because after this, you can differentiate, right? df over dg. Wait, no? How the fraction become one equation? You mean from here to here, right? This part. Do you mean that? Must tell me like which line of the equation, then you can see which line. The g plus f over fg, g plus f over fg. Ah, this one lah, correct lah, this one, right? This one, I think so, yeah. So how I do it is actually, let's say like, I give you a random number, 2 over 3. Let's say I don't give you 2, right? I follow this form. Let's say you forget how to do. Do you know how to do this? Let's say I give you 1 over 2 plus 1 over 3. How will you get the answer? Manually, without using calculator. What will you do here? So I give you 1 over 2 plus 1 over 3. Means instead of f and g, right, I replace the f with the number 2 and g with the number 3. Make the denominator. Yeah, that's what you do. Another way is people will do like this. You times 3 here, you times 3 here, and then you times 2 here, you times 2 here. I think you have seen this method before. Why they actually do this here is because they want to make the denominator same, which is 6. So after that, they can actually do 3 plus 2. Because 6 you divide 2, you get 3. 6 you divide 3, you get 2. So you get 5 over 6 as a final answer. Can you understand this? If you understand this part, then there should be no reason why you don't understand this. You just get maybe like confused a bit because they use f and g, right? Like two variables, right? But actually what they're trying to say is they're just numbers actually. They just confuse you by putting a variable there. It's actually same concept. You see what I'm doing here and here? Only thing I didn't show you times g and times f on both sides like that. But I just do straight over fg. Means I make denominator same. See, 2 times 3 is actually f times g. So 6 is actually fg down here. Then understand it. Good. So you see here. So this is how we do. Other steps, how can you follow? Like after here, go here, all this can. Like from here, you know, you must cross multiply, right? Then only you can do it. Yeah, okay. So from this part, now we stop here. Okay? Now we apply the differentiation knowledge that we learned from to this equation over here. So how we are going to do differentiation for this is slightly long. So I'll try. Because this equation is slightly complex, actually. You see, this one only. Remember, this is the equation we got. We're going to continue from here. F equals negative 15g over 15 minus g. So we come back to the question. They actually want to find the rate of change of f, right? So rate of change of f, what is the symbol we use in differentiation to represent it? Like what is the symbol that we have learned? Like dy over dx, what will we use it here? If I got this equation, means you have to relate the variables in the equation. MS, no, not unit, variables. These two variables. How will you write the next line when you differentiate? How do you differentiate this equation? What's the thing you write? Like just now I saw the formula, right? Remember? This one equals this one times this one. What is the symbol I use there? Thing. Only two variables here. You must notice the one. Means basically like how you proceed from here to the next step. This step is differentiate. Bracket. Why you want to put bracket? Bracket means in terms of what? Which one in the bracket? Bracket 9. Which 9? Oh, sorry, it's in G. But I draw the line down there. Both of these is G. Just now I showed down the negative 15G over 15 minus G. So from here, what is the symbol you'll get? See, you got two variables here, right? F and T. Can you see the two variables there? Yeah. So if you actually differentiate, right, you will actually get df over dg. Just now I showed something like that, right? Remember, dy over dt is dy over dx times dx over dt. Can you see they always use the letter d here? See the letter d there in front of the variable like x or y. D actually means differentiate. That's how you represent the symbol of differentiate. You know, they can just say like y over t equals y over x times x over t, right? So why they put the d here? Everything in this chapter. It's because of the word differentiate. So that's the process we are doing here. So that's a new symbol that we learned in this chapter. Okay. So that's why you say df over dg. How you did this? You differentiate f with respect to g. With respect to g means the denominator is over dg. Means you differentiate the f variable with respect to your denominator of g. That's why we express the equation f in terms of g. Why not moving? What's not moving? You mean move the equation somewhere? What do you mean by moving? Oh, I can't move the equation. Now, okay, huh? Everything clear? Okay, good. So it's not understanding that you differentiate f in terms of with respect to g. So this is how you write it actually. So let's say I give you differentiate y with respect to x. How will you write the symbol? Differentiate y with respect to x. What will be the symbol here? Same concept like that one there. How will you show it? This one is reading skills, like how you read and a form of like this. You translate it into words. Means this part here, like I said, differentiate y with respect to x, what will you get? Use the same thing here. If differentiate f with respect to g, I get df over dg, right? So if I differentiate y with respect to x, what do I get? Follow the pattern. Can you see the pattern there or not? Dx, terbalik. Differentiate y with respect to x. So whenever they say differentiate y, what you're differentiating is on top of this. In respect to is at the bottom. So you get dy over dx. Like this one, differentiate f with respect to g, is it df over dg? Means you follow the sentence. They say differentiate y first, means you put the dy on top. And then with respect to x, the dx is at the bottom. Okay? So yeah, this is one of the steps. So now we are going to apply how we are going to solve this question actually, the real deal of it. So I think earlier when I actually told like a few ways how to solve differentiation, right? I'll ask you a critical question, this one. Let's say from this equation. This one I love. Okay, can I say can you differentiate? Let's say I don't ask yet. Let's say I got an equation y is 3x. Can you tell me what you get after you do dy over dx? What's the value you get? Y equals 3x, then what you get after you differentiate this? First, you must know whether differentiate is integrate or minus the power. I mean, add or minus the power. After you do this, just differentiate. Don't get confused with integrate. So what's the value you will get at the bottom here? Any idea? Remember, differentiate means reduce the power. If I ask you this one x means this x variable on top here is what power? You must know that one first. 1, yeah, correct. So what we do in differentiation is you throw the power to the front. Means 1 times 3, what you get? What is 1 times 3? 3, okay? And then after you throw the power to the front, right? The back power of x, you must minus 1. This is differentiation. You must minus to the back of the power. Means you throw the power front, and then you minus the top of the power. Y equals 3. Yeah, correct. Actually, y, no, dy over dx is 3. Y is 3x. Means you will get dy over dx is 3. Can you see here? If you minus 1 to the power, you get 3x power 0. X power 0 is actually 1. So 3 times 1, you get 3. So this is why I say dy over dx is 3. So this is how it comes from. It's for always when you see like a variable with power 1, you straight away cancel it off. Fast method. You just get the value of the number 3. That's it. So let's say I apply this to this. Can I differentiate this type of equation directly? Like negative 15g over 15 minus g. Can I apply this same method over here? This is a very high level question. You think can I do like this for that one or not? You think can? Second choice? Okay, yes. So how would you do it actually if you want to differentiate that one directly? You must notice this one got a fraction below it, you know. This one there's no fraction below it, just 3x only. Here got negative 15g over 15 minus g. It's not a normal differentiation, you know. See here? The pattern of the equation is different. Because you see here you have an over. That's why when I told, like, I think last week, you got two things here you can choose from. Do you remember the product rule and quotient rule or not? If you have heard of these two, product rule and quotient rule. Yes, you have heard, yeah. So this is why we are doing this here. Because it's a complex equation. Usually product rule and quotient rule we apply to a, I mean, back here. You will see this kind of thing, this word. You will apply it to a polynomial equation. So the word looks bombastic, right? Polynomial equation. So you analyze the word. Poly actually means many. First thing you need to know that, right? Poly means many. Anything that starts with the word poly means many, a lot. Okay. And then nomial, if you learn chapter 5 form 5, you have something called binomial, right? Why they put nomial at the back? You know why? Poly means many, but then nomial at the back, what does it represent? Can you think of any word? Little. Not that. If you put little, right, you will get many little. It doesn't make sense because this is one equation like that. If you combine the word, right, many and little, it's totally opposite to each other. So it's not little. It actually means terms. Nomial, from now on, if you see the word nomial, it means terms. Terms are like this, G, F, F in terms of G, right? You see here, I told express G in terms of F, means it's terms means all this part, over here. Can understand this part. Terms means like it can be 1 term, 2 term, 3 term, like 2x. This is also a term. But here, it's polynomial equation, means if you combine this, right, it means many terms in an equation. This is what they are trying to tell from these two rules that you said just now, product rule and quotient rule. So that's why this equation, right, how many terms does it have? If I say y is 3x, right, it only has one term actually. Because it's just 3 and x, that's it. It's not complicated like this with a fraction at the bottom also. So that's why I said here it's many terms in an equation. And it has operations like minus also. When minus, right, the terms will increase. Usually you'll read 1 term, 2 term like that. So you can see, right, even if you look directly itself, you know this equation is more complex than this, right? So that's why they call it polynomial. Okay. So you need to differentiate. Anytime you see a complex equation, you must think of these two already. These two rules, product rule and quotient rule. Okay, so you need to know that. You cannot do directly like this. You cannot differentiate directly like y equals to 3x. So this is the part that you need to know. So from here, we are going to choose one rule. Okay, let's say. Okay, so I let you choose. You want me to show product rule or quotient rule? Both also can be done. Means when you get this kind of question, right, you can either choose to use product. Okay, one you choose product. So can you give me the formula of product rule? What is the formula you learn? How to do product rule? It's quite long to type out actually. Wait, I show you here. Yeah, this is the formula of product rule. U dv over dx plus v du over dx means you're basically timesing u times dv over dx plus v times du over dx, like this in bracket lah. Easier for you to see. After you times these two, you plus in the middle. This is the formula of product rule. Okay, so you need to get used to it. Like you need to practice more with the formula. Okay, so product rule can be done for this also. So why they actually come up with u and v, right? Why you suddenly see a variable like this, u and v? They'll make an assumption from here. Wait, go here. The equation is this, right? Negative 15g over 15 minus g, okay? So this is the equation. So from here, right, you need to know something that you can either, from here, you have two choices. You can maintain the equation like this, or you can modify it by bringing the denominator up. This one is actually indices knowledge. So if I bring the denominator up here, what would be the power on top here? If I shift, let's say y equals 1 over x, I want to shift the x up, what would be y equal to x power 1 on top? -1, yeah, very good. So same here, -1. So you shift the denominator up here. So the equation will come like this. This is how you apply product rule. If the equation is in this form. If like this form, you'll apply quotient rule. Okay, so it's like this. So the formula actually they will do an assumption here. Let y is u times v for product rule. This is how the u and v comes from. You take y is the equation right here. Let's say the f is y. So it will be u times v. U actually represents this negative 15g, and the v represents 15 minus g power -1. So you need to know that one. Okay. So this is the thing. But for quotient rule, right, the formula you will use is let y is u over v. So I feel that quotient rule is better because the question itself, right, they ask you to express f in terms of g, the one you found just now, right? It's already readily in a division form, means something divides something, right? So it's better if you use quotient rule because the assumption we make is let y equals u over v. Means your u will come -15g, your v will come 15 minus g. Can you see that? You compare up and down. U is -15g, v is 15 minus g. I think you can see that. Just copy back only. From there only we will differentiate and apply this, not this formula, it's just product rule. I show you quotient, not product. For product, it might be slightly longer. Product is if your equation is like this. But this one we already got like this. Okay, so you need to know which one is more suitable to use. Not it cannot be done, but it's just faster in terms of the exam situation. Okay, so we'll try doing this method. That's why if no matter how the question comes, finally you need to know how to differentiate this. Means you have to master the technique of differentiation. This is where you apply your differentiation knowledge. After you modify this equation, right? You come to here, you have to use differentiation after you get this. So you must know lah how to do differentiation. Okay? So this is the thing. So from here, let's say we do differentiation now. I'll introduce the formula first. Let's say I tell the product rule formula goes like this. Dy over dx equals v du over dx minus u dv over dx over v square. This is the formula, complicated, right? You can see here. It's actually more complicated than the product rule formula just now I wrote. So this is how we're going to apply after we differentiate this. Okay, so far can follow, huh? Okay, yeah, okay, good. So from here, right, we're going to do a differentiation step. So wait, let me see. Let me check and see. Okay, so the answer scheme actually used quotient rule, so it's the same thing. So what we are going to do here is we are going to differentiate this. So if you differentiate this, right, what is the symbol you will use here? If u equals negative 15g, what will be the differentiated equation? Can you give the symbol? Like just now I asked you, differentiate y with respect to x, how we write? So now it comes like this. So how will be your symbol? Now I just changed the alphabets only. Nothing is changing. It's just alphabets only. So you need to know how to write it out when you differentiate this. If differentiate, there's always one letter you must have. What is that letter you must know? The alphabet that I used just now. Always I told you everywhere what letter we will have in the equation. Du over dv. Careful of this. This is g, you know. Don't memorize, it's always du over dv. Here I use g. Your du is correct. Modify the behind part. Okay. What will be the answer? The over that part you must modify. Du, yeah, very good. Du over dg. Now you understand why. Because u is negative 15g, so you follow the pattern u, right? So you differentiate u with respect to g. This is what they're trying to tell here. So you need to know what is it in words actually. So after you differentiate this, what you get is negative 15. So I told you, right? Remember when the variable power 1, right? Power 1, you just cut it off. Cut the variable off. You get negative 15. That's your differentiated equation. Okay, so now we do this part. If this part, what will be the differentiated equation? What will I use as the symbol? V equals 15 minus g. Now I'm training on this part, how you write the symbol for differentiate. dg over, careful, this one, follow the equation, v equals 15 minus g. So if I differentiate, follow here, if u is negative 15g, right, I write du over dg. So if here v equals 15 minus g, what will I write? Follow the equation, don't change the letters. dv over dg, yeah, very good. dv over dg. So always follow left to right, then you know where to put it, don't upside down, okay? So what you get after differentiating is, this one is slightly different because it's a negative sign here. So I'll advise you to write it like this. V equals negative g plus 15. This is the same thing. It's actually the same thing basically. I just modify the equation only, okay? So what you get if you do dv over dg is you will get -1 because g is power 1, right? I times the power 1 to the negative, you get -1. And then g will come 0 already. So -1 times g power 0, you get -1. Constant you cut off. Because when you differentiate constant, you get 0. 0 means nothing. -1 plus 0 is still -1. Okay. Then the 15, which 15? That's what I told you. This one cut off already. If you do differentiate constant, right, you will get 0. Y is 15. dy over dx, you will get 0. Whenever something is a number, you will get 0 after differentiate. That's the rules of differentiation that you learn. So it's not you have to accept it. There's no other way, basically. If you want to know, if there's a way you want to know is, I share this way. Y, x, and 0. If I say y equals 15, right, where is your line? How will you draw your line? Will it be a horizontal line or a vertical line, or how? Can you describe the line? If I say the equation of the line is y equals 15. Then is maths, so you learn how to draw a line on a graph. From here, I can bring out this concept that dy over dx is 0. Vertical, let me think. Wait. Vertical is x, don't get confused. Because here x-axis, right, means all the lines that go here is vertical. Because from here, right, y is 0. Remember always your x-axis, right, the y will equal to 0. But your y-axis, your x equals to 0. It's opposite. On the axis itself, the equation is like this. On x-axis, the y will be 0. On the y-axis, the x will be 0. So it's opposite to each other. So if I say y is 15, right, it means I will draw above here. Let's say somewhere here, y is 15. Let's say this point is 15 here. This point, okay? You understand? This part. So I'm going to prove to you now y dy over dx is 0. Okay. So if I say I have a straight horizontal line like this, right? Let me think. Let's say I give you a coordinate here, 8, 15, and this coordinate is 0, 15. Can you understand this? I just put a random coordinate here. It's like 8. On this part, it's reasonable, right? This value is 8. And then here on the axis, on y-axis, it's 0 for x coordinate. You know how to label coordinates, right? Here is 0, 15. Here is 8, 15. Can I accept? Okay. So if I ask you to find the gradient for this line, you know the formula of gradient is y2 minus y1 over x2 minus x1, right? What will you get for your gradient based on these 2 points, 0, 15 and 8, 15? What is your gradient value? If you use this formula. You can label either one x1, y1, x2, y2 as long you label it correctly. You'll get an important number here. You must know what's the value basically down here. Do you know how to sub or not? What is the values you sub from these 2 coordinates? You're still counting, then it's actually quite fast only. You just sub directly only. You'll get your gradient value. Let's say I put here x1, y1, x2, y2. This is the labeling we give for coordinates. How you get 3.3? you mix up the coordinates? It's y coordinate over x coordinate, remember? It's not x over y, it's y over x. Y coordinates is 15. X coordinate is 0 and 8. Must notice the one. Because the first coordinate is always x coordinate, then only comma a y coordinate. So you must know that one first. So if I tell you like that, what will you get at the value of gradient? Let's say I give here this is your x1, y1, means your x1 is 0, y1 is 5, your x2 is 8, your y2 is 15. So you have to sub into this formula. So you see what is the value you get. Can you see the value or not? How you get 2? 0 and 15 and 8 and 15, you know. You see here, if I sub y2, right? y2 15 here, right? And then y1 is also 15, I label here. And then x2 is 8, right? 8 here. And then x1 is 0, right here. Can you see? 15 minus 15 over 8 minus 0. You get 0 over 8. What is 0 over 8? What do you get after 0 divided 8? No, 0 over 8, not 8 over 10. 0 over 8. What is your final value? If you press calculator, so you know only. 0. Can you see the relationship now? Why I say dy over dx is 0. Here also you get 0. Can you see something happening here? Why when I differentiate a line of y equals 15, I get 0? Means what is actually I'm trying to show you here is your dy over dx is actually representing your gradient. Because dy over dx here I get 0, right? The gradient here also I get 0. So I can conclude that your gradient is dy over dx. This is an important concept that you must know in differentiation. Yeah. So this is how I prove it to you. That's the only way for you to accept that you differentiate this, you get 0. You must understand it. So this is how I proved it long way. So okay, understand how it goes about. Very good. Okay, take picture of this. Sounds useful. Always remember this in each chapter because it will be greatly used also. I think we complete this first. We complete a bit more. So this one, right? I just apply this formula, then we can get the answer already. So you see here, right? So I use this formula, df over dg. You have to modify from here, you know. This formula you need to modify a bit because here I use y and x, here is f and g. So you must differentiate. So what you will get is v, I think v du over dg minus u dv over dt. They will switch partners always. Then over v squared. So you sub your values one by one inside. So v is 15 minus g. Make sure bracket is times. du over dg is negative 15 minus u is negative 15g. And then dv over dg is negative 1 over v squared. V is 15 minus g, right? 15 minus g squared. So this is your df over dg. So from here, right, this is why they gave you g is, where is it? One idea. They gave in the question that, they gave the question that g is 20, right? You can see the question. This is where I sub the g inside. This is where I can find my answer. You sub G inside this whole equation is 20. So what you get is 15 minus 20, negative 15, negative 15, 20, negative 1 over 15 minus 20 squared. So your final answer is, you press calculator and see lah. You should get wait, let me see where I get. I will get negative 10.8. Your final answer. You asked to find rate of change of f. Yeah. So that should be your final answer actually. Make sure you times by 1.2. This whole thing you must times 1.2. Because rate of change of f means df over dt, you know. So df over dt is df over dg times dg over dt. So it's this formula you need to use. After you get this value, right? This value represents df over dt, not negative 10.8. Huh? Negative 10.8 is your last one. Your negative 10.8 is actually df over dt. Okay, so you must understand this one. Because the question is find the rate of change of f. Rate means time, so it must be df over dt always. And then this is df over dg. So you apply chain rule. If you want to get df over dt, means you must do df over dg times your dg over dt. This is your dg over dt. They told the question already. G increase at rate of 1.2 cm per second. Okay. So yeah, this is how you do the question. The whole question. Quite long for 4 marks actually to do all this. But this is how you must show in the exam. Okay. Consider the hard question I will say for me. So you must know your process of thought clearly. Okay. So wait now. Can open your camera for a while. Take picture. Okay now. Okay. Okay. Thank you so much. Bye.